Step 3 in the 5 steps of hypothesis testing is to select a level of significance. The level of significance sets a fence that we use to determine if our test statistic is significant, i.e., statistically significantly different. We are doing hypothesis testing. The hypothesis that we test is the null hypothesis. And the null hypothesis states that there is no difference between the sample mean and the population mean. So we are going to establish 2 fences, one on the right and the other on the left. Values over the fence in the purple shaded area, which is called the critical region, are so extreme that it is unlikely we would randomly select a sample with this mean if the null hypothesis is true. The fence is called our critical value. The specific location will vary depending upon our sample, but we will use the same standard to set the critical value every time. That standard is an alpha level of 0.05. We set the fences so that 95% of the scores under the curve are inside the fence, and 5% of the scores under the curve are outside the fence. Here, because we have 2 tails, we will put 2.5% in either tail for a total of 5%. If we get a sample mean that is outside of the right fence, we will reject the null hypothesis. If we get a sample mean that is outside of the left fence, we will reject the null hypothesis. Only if we have a sample mean that is inside the fence will we fail to reject the null hypothesis. Another word for fail to reject is to accept the null hypothesis. But there are some philosophical problems with that word accept, and I'll explain more later. The level of significance is the alpha value. The alpha value is the same as the critical value, both of which mean the same as the cutoff score. What to call it depends on how you're measuring it. If you're talking in terms of how many standard deviations it is from the mean, you might call it a critical value. If you're talking about an alpha level, then you might say alpha equals 0.05. If you're looking at x values on the number line, it will be your cutoff score. Regardless of what you call it, the level of significance is the fence that sets the critical region. So the critical region, also called the region of rejection, is the purple shaded area of the curve. The critical region was set by the fence, and that fence is the level of significance. We want to know whether our sample mean is outside of the fence or inside of the fence. If the cow is the population mean and we are the sample mean, are we on a different side of the fence? Sample and population are different? Or are we on the same side of the fence? Sample and population are the same. Remember that we are testing a null hypothesis that says that the sample and the population are the same. So you should reject the null hypothesis if the sample mean is outside of the fence. The null hypothesis says there's no difference. If you reject the idea that there's no difference, what are you saying? That there is a difference. And that is the logic of hypothesis testing. The most common level of significance is 0.05, especially in scientific and consumer research. In medical research, where quality matters more and the consequences for mistakes are higher, the alpha level is often set to 0.01. Political polling often uses a 0.10 level because the results are not as dire if they make a mistake. For most tests, you should assume alpha equals 0.05 and a 2-tailed test. We will be using that term significant very often. So it's important that you know how to interpret when results are significant. The word significant is an abbreviated way of saying statistically significantly different. So significant means outside of the fence. If your sample mean is outside of the left fence, the results are significant. The sample mean is different than the population mean. If your sample mean is outside of the right fence, the results are significant. The sample mean is different than the population mean. But if the results are inside the fence, not in the region of rejection, then the results are not significant. The sample mean is not significantly different than the population mean. For our example, using baby weight, the alpha level is 0.05. We are using a two-tailed test. So if we had a large enough sample, our critical value would be positive or negative 1.96. Now remember that number, 1.96. It is the critical value, or cutoff score, that we will learn about with a z-test.